Today, I will speak on AI for glaucoma challenges and opportunities. Thanks for inviting me. I'm Dr. Fei Li from Zhongshan Ophthalmic Center, Guangzhou, China. I have no financial disclosure. So here are the 5 main aspects I will talk about today. As you know, that glaucoma is one of the major blinding eye disease in the world right now. And there is a shortfall on the number of glaucoma specialists in both developing and developed countries, so which has become a major public health problem. Artificial intelligence, AI models, has the potential to alleviate the current deficit of ophthalmologists worldwide. They have significant clinical applications in glaucoma diagnosis, in glaucoma image processing, in longitudinal prediction of glaucoma outcomes, and in image modality transfer. So there are many algorithms based on different imaging modalities. They have been developed by different groups of researchers. So the top 3 modalities used in glaucoma AI studies are fundus photos, OCTs, and visual fields. However, in glaucoma AI, there are still a lot of challenges. These challenges can be separated into 2 types. One is the challenges that we have to face in developing the AI algorithms, and the other type is the challenges during the deployment of the AI algorithms. All of these challenges also present new opportunities for us. So let us start with the challenges in developing the AI models. The first challenge we have to face is the labor-intensive data annotation in algorithm development. Data annotation is actually just the first step of developing an AI algorithm. However, it needs huge time and labor consumption to classify glaucoma and non-glaucoma eyes based on the imaging data. Creating large annotated public datasets is actually an effective way to solve the problem. But currently, the existing public datasets have several issues like limited sample size, lack of uniformity of ground truth labels, deficiency of cross-device data, and also the absence of clinical derivation, and then universal evaluation framework. So all of these problems need to be solved before we can create a really useful public data set. Second challenge we have to face is the poor generalizability of the current AI models we have in glaucoma. So when an algorithm is developed, the researchers always pay attention to the generalizability of the algorithm. There are many reasons for the poor generalizability of the algorithm. So here we have summarized some of the main reasons. One reason is that for different studies, we use different diagnostic criteria, like what we have summarized in this table. Even for the same aim, which is diagnosing glaucoma based on fundus photos, we have various diagnostic criteria to say what is glaucoma or what is glaucoma suspect. So one model developed in some study usually cannot have the same performance in another study. Another reason for poor generalizability is that different studies have different application scenarios. For example, so in this slide, this is one study from ophthalmology. The researchers, they developed a model based on the fundus photos. So all of the glaucoma they detect are actually glaucoma suspects. So when they test their model in glaucoma patients that are diagnosed by OCT and visual field, their performance has a very huge reduction, as you can see. the third reason for poor generalizability is that many of the studies, they don't have external validation. So the researchers actually don't know the performance of their models in other people's data. So we reviewed all these glaucoma AI studies and found that a lot of them, they only test their data in internal validation data set, and there's no external validation. So we are not aware of the performance in external data. The third challenge we have to face in developing glaucoma algorithms is the relatively poor interpretability. Currently, the most popular way to explain how the AI model works is to generate heat maps. So in our research, we usually use GradCam, a very popular toolkit to generate heat maps. These heat maps help us to point out the key regions in glaucoma diagnosis and prediction. So as you can see in this slide, we show different heat maps from our serial studies. Although the heat maps show that AI algorithms use key clinical regions to diagnose glaucoma, but actually the AI algorithms, they just know that the key regions are associated with glaucoma, but they don't know why these regions are the indicators of glaucoma. So there is still room for the explanation of AI models, because currently the explanation algorithms, they don't have logical decision rules or explanatory terms, and also these heat maps, they cannot support real clinical decisions, because they just show you the association, but they just cannot tell you why. And also they just tell you the superficial associations, and they don't provide you the insight how the underlying mechanism works. So now let's move on to the next part, the challenges in glaucoma AI model deployment. The first challenge we face in this part is the poor adaptability of AI algorithms. So one reason for poor adaptability is that most of the AI algorithms are developed based on homogeneous population. Say Chinese researchers, they usually develop AI models using Chinese people's data. For Americans, they usually use the data from US or Europe. When these models are tested on a different data from other countries, the performance may get worse. Another reason for poor adaptability is that models, they are not sufficiently fine-tuned on different types of data. So we can see in this figure that now most of the data, they are collected from more developed countries or regions like the US, China, also India. But for countries in South America, in Africa, also, as you can see in Oceania, the number of data sets are quite less. So most of the AI algorithms are developed based on the data from these main countries, and we suspect whether these models can also perform well, in other countries. Another problem we may face in real-world deployment of AI algorithms is that we usually obtain low-quality images in the real world. So how to deal with these low quality images? Because low quality images directly leads to a worse performance of the AI models. So we may have to think about some ways to maybe identify the images and ask the technicians or clinicians to recapture the images during real-world deployment of AI algorithms. So this part is over, and now let's move on to the opportunities in deploying glaucoma AI. As you know, that I mentioned, one challenge in developing AI is that we need a lot of time to label data and collect data. So if we can share data freely and fluently in research, then that challenge may be solved, right? One possible way is that we use some privacy preserving frameworks. So this enables us to share the data, but still keeps the privacy of the data. Another possible solution is that we use fake data, which is generated by AI. And then we don't have to worry about privacy. We can use these synthetic data to train new AI models and to enhance their performance. So there is already some studies published in ophthalmology related journals like TVST. So this one, it uses synthetic OCT data to train glaucoma diagnostic models. And as you can see that the addition of these synthetic data really help enhance the AI model's performance. Another opportunity is that before imaging data, we can also collect other data to enhance the performance of the AI models. Other data, such as EHR data, and even the sequencing data. So in some of the studies from ophthalmology journals, they use omic data. So omic data and imaging data are combined as the input into the AI models, and then the AI models diagnose whether the patient has glaucoma or not. Hopefully, we hope that this method can enhance glaucoma performance, but in several studies, they prove that the combination of omic data and imaging data doesn't enhance the performance. But still, we need more research to prove this hypothesis. The fourth opportunity is that we can use smartphones. Smartphones combined with AI algorithms will lead to some breakthrough in the point of care service in glaucoma. So currently, we can use smartphones to capture fundus photos, to perform visual field test, and even IOP monitoring. So all of these are very common and important for glaucoma management. So with a single smartphone and AI algorithms, we can conduct glaucoma telemedicine. So the last opportunity, and I think this is the most promising one, is that now we have large language models. So the emergence of large language models like ChatGPT, like Llama, like Google Palm, all of these large language models, they have very much more power and abilities than previous convolutional neural networks. So they can handle multimodal inputs and also have dynamic interactions with the external environment. So theoretically, they can solve all of the challenges we have talked about, like identify the poor quality images, like interaction with physicians, like explaining the photos to physicians and patients. So in conclusion, we now face both challenges and opportunities in glaucoma AI. We still haven't reached the end for glaucoma AI, and among the opportunities, large language models. When we use them as interactive medical agents, they may bring some groundbreaking shift in healthcare paradigms of glaucoma. So thank you for your attention today. That's the end. Thank you.